Hey guys, welcome to this new video on DAC algorithm. And in this video, I'll be talking about the second implementation, which is finding power of an element using DAC algorithm. So let's see how to find power of an element. So the input will be two integers, a and n. A is greater than 2 and n is greater than 1, where an output will be a to the power n. So let's say if you are given 2 and 64, you need to find 2 to the power 64. So this is a and this is n. N is the exponent, a is the number for which you want to find the find the power of that element, like 2 to the power 64 I want. So a is 2, n is 64. So what will be the, like, if I want to, like, for example, if I want to find 2 to the power 64, we can write what 2 to the power 64 can be written in 2 to the power 8. Sorry, 2 to the power 64 can be written into, no, let's say I have 2 to the power, sorry, a to the power n. So I can write it as a to the power n by 2 into a to the power n by 2. This we can write. For example, let me take an example. I have 2 to the power 8, so I can write it to the power 4 into 2 to the power 4. If I have 2 to the power 4, I can write it as 2 to the power 2 into 2 to the power 2. So how the recursive tree will look like? So if I have n, let's say I want 2 to the power 64. So n is 64 here. So I want n by 2, n by 2. So what I want to find out 2 to the power n by 2, a to the power n by 2 first. Then I can do n by 4, n by 4. So if I draw the same tree with respect to 64, which I used, it will be 32, 32. Or if I want to say a to the power 2 to the power 64 will be equal to, I'm dividing it, so it will be 2 to the power 32, 2 to the power 32. Again, I will divide this 2 to the power 16, 2 to the power 16, to the power 16, to the power 16. So you can see it is coming on this side also, the same thing. So what we can do is we don't need to find this side of this tree. Also, this side is not required, because when we will be combining this and this, you can see 2 to the power 16, 2 to the power 16 is same. So what we can do is like multiply this two times, then it will be solved, because here we are dividing, and when we are combining these two only. So this finding this is not needed here. Is that like an extra step which will take extra time. So we can skip this tree also. So what we can do? We can do 2 to the power 8, 2 to the power 4, 2 to the power 2, 2 to the power 1. And this is our base case. So here n is equals to 1. So when n is equals to 1, we return a. Here a is equals to 2. So our small problem, which will be our base case, which is the base case in our recursive program, will be the small problem. So let's see what's the small problem. Small problem is if n is equals to 1, we will return a. If it is not that, what we will do? The code will be like this. So let me copy this code. Yeah. And the big problem will be if n is not equals to 1, like if n is greater than. So what we will do? We will divide. Why we are dividing? You can see we are dividing here, dividing it by 2. So we will take mid is equals to n divided by 2. And then we will find, let's say the name of the program is DAC pow. Sorry, the name of the function is DAC pow, and I am sending a and n. So this part is for the small, and this part will be for the big. This will be else. So what I can do, DAC pow, I can call DAC pow, and I can pass a and mid, which will give me the output. So if my n here is 64 and divide by 2, what I got 32. So this will give me a to the power 32 answer, and it will go inside and do recursive calls. And so at last, when the recursive call will finish, it will come and give me the power, the result of a to the power 32. So b is equals to a to the power 32. So I have to do it multiply it twice, because here you can see when we're combining, we're multiplying. So if my combine algorithm will be C, let's say combine is a function which accepts the result of the smaller subproblem. So what will be the combine algo? So combine accepts B, returns B into B. This will be the combine algorithm for this divide and conquer algorithm. And last, what we'll do? We will return C. So this is our problem for finding the power of an element using DAC. So let me write the program in a clear way, so that it will be better for you to understand. It is like DAC pow. We have a comma n. If this is the small part, if n is equals to 1, what I will do? I will return a. That's what I will do. I'll find the mid, which will be n by 2 floor. Then I will call DAC pow again recursively to get A mid, and we will store it in B. Then we will combine and put the result in C. And we will return C. So this is our program, and the combine algorithm will be, it will take B and return B into B. So this is for a small problem. And this is for a large problem. And this one is the combine algorithm. So this is how we can find. So let's now find the time reconciliation for time. As I have told you, you can write reconciliation for anything like time, space. So here I am writing reconciliation for time. So why we need to find the reconciliation of time? I want to find the time complexity of this DAC power program. So to find the time complexity of recursive program, you need to get the reconciliation. So T of n will be equals to O of 1. This is for the small. N is equals to 1. Or else it will be, this will take O of 1 time. This will take T of n by 2 time. And this also will take O of 1 time. So we'll take O of 1 time, and that means a constant time. So I can write C plus T of n by 2 plus C. This is the dividing time, this is the combining time. And then what I will do, it is for n is greater than 1. So this is the reconciliation. So I can write this as T of n by 2 plus C, T of n. If we solve this, we will get the time complexity. So this will be equal to. So how we can solve this? We can solve this using the substitution method. So let's find this T of n by 2. What is the value? If I use T of n by 2, this will be T of n by 4 plus C. If we put this, so what is this? What is this T of n by 2? This is the cost. Just a minute. I will tell you. If I have n here, n by 2, n by 2. This is the cost of dividing n by 2 into n by 4. Got it? Like, what is this? This is the cost of dividing n by 2 to tn by 4. So this is the cost of dividing tn by 2 to tn by 4. So since we are not going this side, so this we will not take. So the total cost here is C. Here also it is C. Let's see what is the total cost as T of n by 2. Sorry, T of n by 4. So the equation was T of n by 4 plus C. This is for this one, and I have another C. Let's find T of n by 4. So T of n by 4 will be equals to T of n by 8 plus C. So again, this T of n by 4. So the cost at this level to divide T by 4 into T by n by 4 to n by 8 is, this is the cost, it will be same C. So at each level you can see the cost is C. So I will have how many levels? I will stop at n by 2 to the power k, let's say, and I will stop at when n is equals to 1. This whole thing becomes 1. So n by 2 to the power k is equals to 1. So k is equals to log n. So I will have log n levels, and so the cost will be at this level. If you will be also C. Cost at this level will also be C, and I have to, for time finding the time complexity, what I can do is, if I do sum, what will get? K C. What is K? K is the number of levels. I have C at each level, so if I sum it up for each level, it is C. So for K levels will be KC. So it will be C log n. So this will be the time complexity of this power of an element algorithm, which will be O of log n, and it will be for every case. And also, if I put the same equation in this same which we got in this equation, what we will get is T of n is equals to T of n by 2 to the power k plus kc. So we want n by 2 to the power k to be 1. So this will be T of 1 plus k value is log n, c log n. So we got T of n is equals to c log n. From here we also can find the time complexity. So how many levels will be there in this tree? We can see if we have 64, we did 32, 16, 8, 4, 2, 1. So 1, 2, 3, 4, 5, 6 levels. So log n levels. We will have log n levels. So level is equals to log n. And what will be the space complexity? As we know in recursive program, the space complexity is the height of the tree that you create during recursive call. So space complexity will be log n height of this recursive tree. As we know, the space complexity of recursive program is the height of the recursive tree. So this is how you can find the power of an element using DAC algorithm. Thanks for watching the video.